Hello viewers, welcome to Big Boy Physics. In today's video, I'll be discussing about vectors. This is the second lecture of the topic Basic Maths. Today's video will be devoted to addition, subtraction, all those stuffs, and a few definitions of vectors. Okay, so let's get started. Well, I hope that I don't need to give you a broader difference between vector and scalars. You all must know it before, but still I am just giving you the definitions. What are vectors? Vectors are those quantities which have direction. I'm writing it as dir n in the superscript, as well as magnitude. Those quantities having direction as well as magnitude are called vectors, and examples are velocity, displacement. There will be numerous types of example: displacement, force, then all those stuff. Torque is also torque. You may also not know about it if you are starting 11th. You just keep it limited to force, etc. Now, what are scalars? Scalars are like 2 kg प्याज और 2 kg आलू, दोनों को जोड़ेंगे तो 4 kg सब्जी मिलेगा. ठीक है, तो scalars वो होता है, those are those things which only have magnitude. And we well just if you want to know that what is the direction of the potato, what is the direction of the onion, we can't say unless we can throw the potato and onion. Well, if you even throw it, they will get the direction of its velocity or the momentum, right? So we cannot define the direction for onion potatoes, but onion potatoes are not scalars. Just to remind, onion potatoes are not scalars. Their masses are scalars. The mass of an object is scalar. If you talk about weight, no, weight has direction. Suppose this is a block of mkg, then if this is my earth, it's not flat. Just when you look it from a very large radius, then it looks like flat. So it will try to pull this block with mg, where g is the gravitational force of acceleration, gravitational acceleration constant, and this is the direction of the weight. And mass is basically the amount of substance present in an object, that is mass. You can also say another thing, that is work is a scalar quantity, kinetic energy is a scalar quantity. These do not have their own directions. Okay, so these are just basic definitions of vectors. Now coming to representation of vector, representing vectors. Now to represent a vector, what we do is the vector generally have two components. First is the head, uh, first is the tail and a head. A vector points its direction from the tail towards the head. Okay, basically a vector is represented by a line or a ray, better to say a ray, joining from the tail to the head. Then this direction I'm marking with red, this direction which is parallel to the vector, I'm just showing this direction. If we look towards this direction, this will give the direction of the vector, and the length of the vector basically represents the magnitude. Well, this figure is not to scale, so don't mind. This represents the magnitude, the length of the vector. We can say also one thing, that magnitude I'm writing as a mg only, mgn. Magnitude is proportional to the length of the vector. Yeah, this is a very important thing. You must know that magnitude is generally proportional to the length of the vector. In most of the cases, these are not to scale, so don't worry about these. Okay. Now, one thing is about equality of vectors. Two vectors, two vectors are equal if both of them have same magnitude and same direction. These are two important conditions fulfilled by two vectors for their equality to hold. Now assume this is first vector, vector 1, and this is second vector I'm marking by yellow, vector 2. If the magnitude of vector 1 is equals to magnitude of vector 2, let us represent by a1 and a2. If mod a1 is equals to mod a2, then we can say both of them have same magnitude. If and since I have drawn them parallel, they are actually parallel to each other. This implies that they have same direction. But observe that their tails are shifted. The tails I am marking by black are actually not coinciding with each other. But still, we can say that these two vectors are equal. Vector equality does not only mean that their tails should coincide. Their tails may vary. Just only two conditions to be satisfied: same magnitude and same direction. Bus. Do not look for any other thing. Just look for these two things: same magnitude and same direction. And this way we can say that two vectors are equal. Well, equality of vectors will not be asked in exam, so we don't need to do some kind of PhD in this topic. Now coming to the portion where the examination and further physics takes place, which will be helpful for learning more physics and all those. Okay, that is addition of two vectors. From now we are starting the mathematical portion. Addition of two vectors. हमने पहले भी बोला था आलू प्याज का पात कि 2 kg आलू है 2 kg प्याज है, तो हम लोग जो टोटल वेट कहते हैं उनका 4 kg जो सारे चीज़ों का मास है. बट इन केस ऑफ वेक्टर whatever we do means अगर एक वेक्टर का if a vector has a magnitude of 4 and another vector has magnitude of 3, the resultant will have 7. We cannot say exactly. There will be some cases where the resultant will be 7, and in some cases resultant will not be 7. So how can we add two vectors? Suppose I have two vectors. A vector I am representing by red color, and a B vector I am representing by green color. To add these two vectors, there are two methods. First method is triangle method. Triangle law of addition. To do this, what we do, if we need to find A vector plus B vector, put a vector, the A vector here, it is its tail and this is the head. I'm marking the head with yellow color. Now, the second step is to put the tail of B vector to the head of the A vector. Now, put the tail of B vector to the head of the A vector. Yeah, like this. Okay. So you get a triangle. Now, what will be the resultant? Resultant will be the line joining the tail of A vector to the head of the B vector. This is called the resultant vector of A vector plus B vector. So we represent it by A vector plus B vector. So we can say that the line joining the tail of the initial vector to the head of the final vector is basically the summation of the two vectors. Now, assume that the angle between the A vector and B vector to be theta. Then do you mean that this is theta or this is theta? A quick question. So those who have studied vectors previously, they may know that this is actually theta. This is theta because what we do to find the angle between the vector, we connect the tail to tail. We connect the tail to tail and find the angle theta. If we try to connect the tail to tail, or we can extend the A vector here, you can observe that if we extend the A vector further, the angle between A vector and B vector will come out to be theta. So in this, to find the angle, we generally consider both the vector to be some kind of line. Okay, these two are some kind of lines, and the lines intersect at an acute angle of theta. Yeah, that's the way to calculate the angle. We generally put the tail to tail. Hope you get it. Now, to find the resultant, we'll be doing a little bit of trigonometry. This has length B and this has length A. So what will be this length? B cos theta, and this length would be B sin theta. Now, if you want to find mod A vector plus B vector whole square, it would be A plus B cos theta. This is the magnitude of length. Suppose this is a triangle A, B, and C, and this point to be B dash. So we can say that by Pythagoras theorem that AC, which is represented by AC, which is equal to A vector plus B vector, AC square is equals to AB dash square whole square plus B dash C whole square. Now AB dash is equals to A plus B cos theta whole square plus B dash C is B sin theta square. Now just expanding it, you will get mod A vector plus mod B vector is equals to A square plus B square plus 2AB cos theta, and if you take the under root, you'll get the magnitude of the resultant vector. Yeah, so this represents the magnitude of the resultant vector unit, and this is often used in the problems. And if you want to find the angle between the resultant vector and any vector, suppose a vector, then you can say tan alpha, I'm marking by alpha here, tan alpha is equals to b sin theta by a plus b cos theta. Okay, yeah. So this is a important theorem. These two are two important things you must remember to solve any problem. And another thing that AB cos theta, we generally write it as A dot B. It's written as AB cos theta. We'll be talking on dot products and cross products. Nothing to worry much. Okay. Now let us see few questions regarding this concept, that is addition of vectors. So yeah, before that, before picking any problem, now we'll be defining another concept, that is multiplication with scalar. Multiplication with scalar. Suppose I have a vector A. I'm marking with a red color, A vector. This is a small vector. If I multiply a number where k belongs to a real number, then what will be k vector? Then what we do to find k vector, we just draw a line parallel to the a vector. This line I am drawing with green color. This line I am drawing with green color is parallel to the original a vector, but its magnitude is multiplied with k times. Basically, if this magnitude is a, then the magnitude of the green line will be ka, and we represent this by ka vector. I can say the conclusions from it are that k a vector is parallel to the a vector, and mod k a vector is equals to k times mod a vector. That is, we'll generally do what is we'll multiply the magnitude of the vector with the real number we are required. Then we'll get the magnitude of the new vector. So hope it's clear. Now there may be cases where k will be negative. Suppose k is negative 1. Suppose k is negative 1, then what do we write, that will get minus a vector. What minus a vector represents is basically a vector. If this is the a vector, minus a vector will represent the same a vector but in opposite direction. Basically it means that a vector and minus a vector are anti-parallel. Anti-parallel implies that both are opposite to direction. If this is a vector, this is minus a vector. This is the meaning of the concept, that is anti-parallelity of the vector, and this is the thing which we use while doing the subtraction of vector. Let me show you an example. A vector plus B vector. This is A vector, this is B vector, and the resultant I am marking with dotted one is A vector plus B vector. If you are told to find A vector minus B vector, just reverse the direction of B vector. You can write it as A vector plus minus of B vector. So we are just reversing the direction. Yeah, the same magnitude to B, but in opposite direction we'll write minus B vector. Hence, the resultant will come out to be A vector minus B vector. And if you want to find the angle between A vector minus B vector, you can do the same calculation. But for now, I am talking about magnitude. A vector minus B vector mod is given as A square plus B square minus 2AB cos theta. Just observe the difference. In case of addition, we got it plus 2AB cos theta. In case of the subtraction, we got a minus 2AB cos theta. This is the difference between the evaluation and calculation. Okay. Now we also covered subtraction of vector in this method. So now we will be focusing on few simple problems and learning how to solve problems regarding this concept. Coming up with the first problem is just basic theoretical problem. The first problem says that suppose you have written a vector plus b vector plus c vector, and this diagram is given along with it. The diagram is somewhat like this. This is a vector, this is b vector, and this is c vector. So you'll get the resultant, the line joining from c vector to a vector, that is the head of the c vector and a vector. This is the resultant r vector. Now the task you have to do is find a vector plus b vector minus c vector. Means how you'll approach the diagram so that you'll get this a vector minus b vector, a vector plus b vector minus c vector. Just redraw this diagram to find this a vector plus b vector plus c vector. Okay. So what we'll do is just reverse the direction of c vector. I'm representing with a file pink color. So this is minus c vector, and from here if you connect the line joining the tail of a vector and head of minus c vector, you'll get the resultant vector r vector. Okay. Hope you get it. So this was just a simple calculation, not even calculation. It was just a kind of a theoretical problem. Okay. Now let us do another problem, another simple problem. Question 2. Question 2 says that the greatest, the maximum, and minimum resultant forces acting on a point object is 10 newtons and 6 newtons respectively. Now the question says that if each of the force increased by somewhat 3 newtons, find resultant when both of them are at 90 degrees to each other. Okay, so let's get started. Now this concept is about maximum and minimum force acting at a point. We can do this by thinking a little bit of visually, or a bit of just mathematically. If you remember the resultant force a vector plus b vector is given as under root a square plus b square plus 2ab cos theta. Now you know that cos theta varies from -1 to +1, so you can say that the maximum would be when the cos theta will be +1. So you will get it to be a square plus b square plus 2ab mod under root. Observe that this is a plus b whole square, so you can write mod a plus b, this first one, and minimum is when cos theta is -1. Minimum would be under root a square plus b square minus 2ab. If you further evaluate, you will get mod a vector minus b vector, or the magnitude. Just we are writing dealing with magnitude, so mod a minus b, where a is the magnitude of the a vector and b is the magnitude of b vector. For now, let us assume that a is maximum of them. A is maximum of them. Then the maximum force is equals to a plus b, where a and b are positive because they represents the magnitudes. Even one thing you must know, that if minus a vector is there, then magnitude of this minus a vector will be mod a vector, which will be basically a. So magnitude of any vector is always positive regardless of its direction. So yeah, maximum force is a plus b, which is equals to 10. Minimum is a minus b, which is equals to 6. Just two linear equations in two variables. We'll get a is equals to 8, b is equals to 2. As per the question, they are saying to increase each of the force by 3 newtons. and make them at angle 90 degrees. So yeah, this is first force. A vector is 8. I am considering it to be 11 newtons, and B vector increased by 3 is 5 newtons. So resultant R would be just the angle under is 90 degrees, so A square plus B square plus 2AB cos theta. Cos theta, where theta is 90 degrees, should come out to be 0. You'll get under root 11 square 121 plus 25, which is equal to under root 146. Yeah, so that's the answer. Hope you get it. Yeah, in newtons, of course. Now we'll be doing more amount of problems. Just before going to the next problem, I'll be showing you another method to calculate the resultant. Method 2, to find addition of vectors. This is called the parallelogram method. Well, if you read this method, you'll find it similar to the triangular method itself, but still we are dealing with this parallelogram method. Okay. Now, what we do in parallelogram method is just we connect the tail to tail. Suppose here's my vector A vector, and I'm marking with pink color, and this blue color represents my B vector. Then the resultant is found by this method. Translate this capital A vector. Translate this capital A vector parallel to B the itself by connecting its tail to the head of B vector, and this B vector like this, the same method as I've described for A vector. This actually represents the net vector, that is A vector plus B vector. So this is the parallelogram method of addition. Well, it is similar to the triangular method. I don't need to explain much of them, but still I just covered it for the sake of knowledge. And there are few properties of addition of vectors that are: first is commutative. Commutative. A vector, suppose it's written A vector plus B vector, we can also write it as B vector plus A vector. Second is associative. Associative. If there are three vector, A vector plus B vector plus C vector, if we consider them to be one of the brackets, this B vector and C vector, it is equivalent to A vector plus B vector whole bracket plus C vector. Right? Hope you get it. Okay. Now it can also be, you can also further write it as A vector plus C vector whole plus B vector. Okay. So we are just done with everything and all those stuffs. Now coming back to problem solving. Yeah. If you remember that I just have recently taught you about the maximum and the minimum forces, minimum magnitude of vectors. If you want to find this, let us assume that A vector and B vector are two vectors in which angle between A vector and B vector is variable. So if A vector is maximum of them, what we do is we put the E vector here, and what can be the possible locus of the head of the B vector? The possible locus of head of the B vector is this circle, right? The possible head of these B vectors, possible locus of the B vector's head is basically this circle, right? Its distance from the center, that is the head of A vector, is constant. Now observe that the maximum distance between the tail, or that is I'm denoting by pink color, and the head I'm denoting by blue color, will be when both of them are collinear. Not yeah, it's collin, not even, yeah, collinear. When both of them are collinear, then we can say that both the vectors are in maximum or minimum. In this case, the maximum would come out to be A plus B, and minimum is when this B vector will be pointing to the opposite direction of its maximum case. Minimum would be A minus B. Now observe one thing, you'll be thinking that why I didn't take this to be in some other method. Just a minute. Some mishap occurred. Okay, you might be wondering that if we consider this B vector to be the fixed vector and A vector to be variable vector, Yeah, of course we can do that. See, here's b vector, and a vector in this case would actually enclose the b vector. This is the maximum case and this is the minimum case. The same thing is occurring in this case also. So yeah, we just covered till this. Now coming up to the next problem is, suppose resultant of p vector, there are two vector p vector plus q vector, and their resultant is given as r vector. Now they are saying that if q vector is doubled, then r vector is also doubled. Second thing, this is the first point. Second point is, if q vector is reversed, then again r vector is doubled. The question is to find the ratio of the magnitude of p vector is to q vector is to r vector. Basically, you have to find the ratio of their magnitudes. Try this question, pause the video. Now I'll be getting started. So yeah, first thing we'll be writing just the magnitudes expression. I'm writing with red color. R square is equals to p square plus q square plus 2pq cos theta. Now when q is doubled, r is also doubled, so you'll get p square plus 4q square plus 4pq cos theta is equals to 4r square. Now q is reversed, so you'll just put in second case is that q is substituted by minus q. Just put it and you'll get 4r square is equals to p square plus q square plus minus 4pq cos theta. Now we have to get rid of this cos theta term first of all. So before that, we'll be finding all these calculations, doing all the calculations. Okay. Now to get rid of, we'll be adding the second and third equation. We'll get 2p square plus 5q square is equals to 8r square. This is the first case. And second will be, just multiply this first equation with 2 and subtract from the second equation. Let me mark them with first, second, third. We are getting this first equation by second plus third. And second equation will be doing what is second minus 2 times first, will be getting 2r square is equals to 2q square minus p square. So yeah, now we got two equation. You'll be wondering that there are three variables, how can we find the magnitudes? Well, you don't need to find the magnitudes because they're asking the ratio of the magnitudes. So we'll get a relation between p and q in terms of some ratios, and we need to solve it. Multiply this equation by 4, you'll get 8q square minus 4p square is equals to 8r square. Subtract from equation 2 plus 3, you will get 3q square minus 6p square is equals to 0. From where you will get 2p square is equals to q square. Right? This means there may be some calculation errors. Yeah, sorry, it will be 2 here instead of 4. We need to solve it again. Now what we'll do is add first and third equation. From here we'll get 5r square is equals to 2p square plus 2q square. Now second plus 2 times third will be getting 12r square is equals to 3p square plus 6q square, right? From here we'll get 4r square is equals to p square plus 2q square. Subtract these two equations, you'll get p square is equals to r square, and since p and r denotes magnitudes, both will be positive, so I can say p is equals to r. Now I'm basically subtracting these two equations, so you'll get P equals to R. Hence you can say Q is equals to root 3 by 2. Just putting the P is equals to R in first one plus third equation, you'll get PQ is equals to root 3 by 2. Hence you'll get P is to Q is to R is equals to 1 is to root 3 by 2 is to 1, and multiplying with root 2 you'll get 1 is to root 2 is to root 3 is to root 2, and that's the answer. Hope you get it, right? Yeah. So these are few problems I have taken it from few JE books and all those. Now, if you want to solve more problems, I'll be bringing another session for you. If you just write down in the comment section to bring some more problems on vector, I'll be doing some more problems because it's not a topic in which you'll have to do much of PhD, all those stuffs. So I'm just keeping few number of problems. Well, to solve more problems, you can follow any other J books like Cengage or Etziverma has plenty number of problems. So yeah. And another case I want to discuss with you all is that the concept of three vectors. If you have three vectors, A vector, B vector, and C vector, all having same magnitude, you have to find the angle between each of the vectors so that A vector plus B vector plus C vector is equals to 0. Now you can think of one case where the A vector, B vector, and C vector are equally inclined. Well, this is the only solution you can verify that this is the only solution to this system for having a null vector as the solution. So what is null vector? The resultant of the when resultant of all the vectors comes out to be 0, then we define it to be a null vector or a 0 vector. So we generally write it 0 because the 0 vector does not implies anything in any direction of those. That is why we write it simply to be 0. And the last topic of today's lecture is unit vectors. What is the use of unit vectors? Unit vectors actually gives the direction of the vector. Suppose you have a vector. I'm again taking the same A vector. Okay, for if you are irritated with A vector, I am taking it to be D vector. D vector. This is a D vector. Now you know that a D vector will have some magnitude mod D vector, and direction is along the line joining the tail of D vector and head of the D vector. If you want to find the direction of the D vector, if you want to define direction of D vector, what we do is that we consider a small line which is along the D vector, and this direction we represent is by mod D vector by mod D vector is written as D cap. This D cap basically is a unit vector with the direction along the D vector. D cap is the direction of the unit vector along the direction of the D vector. Okay, hope it's clear to you. And unit vectors are basically, you can write it this D vector as a D, where D is the magnitude of D into D cap. So this is D vector. Well, if you want to write any vector in terms of this, suppose you have A vector, and A vector points towards A cap direction, and it has magnitude of A vector is equals to 5. Then we can write A vector is equals to 5 A cap. But A cap is the direct unit vector along the A vector. If you want to define negative vectors like minus A vector by mod A vector, basically represents a unit vector anti-parallel to the direction of the A vector. This is minus A cap, and this minus A cap is in the opposite direction to the A vector. So yeah, if you will be talking about unit vectors in the next video, when we'll be talking about taking the components of a vector along the xyz axis, and in the next video we'll be talking about dot products, cross products. If possible, we can talk about scalar triple and vector triple products. If not possible, we'll be talking about in the next video. Okay, so that's it for today. Thank you and have a nice day.